what are some of the most meaningful strategies that you guys are finding today for reducing double-stranded RNA production? So maybe we'll start with Stuart and then go to Christian and then Mark.
Sure. Yeah, I found the easiest and most low-hanging fruit are these new, there's a lot of them out there, engineered T7 polymerases. So people are trying all sorts of strategies, whether it's thermostable ones that you run the IVT at a higher temperature and that reduces dsRNA formation, or just ones that have more specificity for the promoter sequence.
Yeah.
I've seen a lot of success using those engineered polymerases.
Okay.
And there's more than one out there on the market too, for sure.
Yeah.
But you can see drastic reductions in dsRNA formation using those polymerases in your IVT.
Awesome. Okay.
So, that's probably the best strategy I've seen. I know people are evaluating like solvents and chaotropic agents and optimizing NTP ratios, but I think the polymerase will get you the most bang for your buck. Yeah.
Okay. All right. So innovation in the supply chain's working magic here for us, working miracles. Christian, what about you? What do you see? What do you see the field working on that's exciting to you?
I generally would agree with Stu that avoidance is the strategy to follow instead of getting rid of it afterwards. But I know double-stranded RNA is a big topic in the community. However, we have within our batches we have been producing have never observed relevant formation of double-stranded RNA. We've thrown every assay on that's currently available, which is a bit heterogenic, but with different qualities, but we have never observed something. I have to be fair, we do not exactly know what is the driving factor, why we don't see it in our conditions, but as we don't see it, we focus too much on that. We have indications that IVD conditions are definitely one of the aspects that lead to formation, because if you change things there, we see that popping up. But so bottom line, we do not see it. We do not focus on it too much, and that's my favorite strategy.
That's your favorite. Well, actually, that's interesting. I'd ask the same question, but are there, one of the arguments I've actually had some folks ask me, well, is double-stranded RNA really that big a deal, right? We're still trying to figure that out as well, right? So are there other impurities that you are more, that you're directed towards more so today, right? That you're trying to tackle? Are there impurities that we as a field should be talking about just as much as we are talking about double-stranded RNA?
Well, that's a good question. So it's a bit difficult because it's asking about the unknowns, right? I know it's topic of the of the discussion today, but as scientists, I would say, hey, throw everything on mRNA. Just let's find out if there's something we do not see in the moment, which might be problematic. But on the other hand, as stated before, I think developing a drug, we have to check what's relevant and what is not relevant. And not easy to answer, but I think that's the focus. I think a few years ago, mRNA was quite new, just a niche product, and developers have been working on that. So that changed a lot, I think. Now products are on the market. Everyone has access to the material. A lot of people are testing the products as well, and they're publishing their work. Scientists of the field, but also very critical people. I think that's excellent because we just can learn from that, and it more or less validates really safety of these drugs, right? Because if you're searching for something and you see there is nothing really harmful in these drug substances, also not in the drug product, that's I think something great. And I heard Stu saying that LCMS is a bit more difficult, but I think LCMS has provided a lot of information on characterization of mRNA, did a great job there. So I think we know a lot on the processes and on the impurities that are available. I think it's more the question on the relevance, on what we see and what we try to avoid, where we have to focus more on.
Okay. We did have a question from the audience that ties into this. neatly. And then Mark, I want to jump to you. But first of all, maybe this is a good one for Stu to address. Many groups have shown that optimized IVT conditions can reduce dsRNA while keeping high yield. What trade-offs do you see with novel T7 polymerase, and do they justify the cost of novel reagents?
Yeah, they're definitely not plug and play necessarily to your IVT. You can't just drop a new polymerase in and expect to get the same yield. But with a little bit of optimization, these engineered polymerases can definitely achieve the same yield as a wild type. So I'm not super concerned there. I guess the big trade-off is like the cost of the engineered T7. They're way more expensive than maybe a wild type. But hopefully, as production scales, that cost will go down, and you can also optimize your reaction to use as little of that as possible. But I would say that's the biggest downside is the cost.
Okay.
For sure.